The scientist I chose for my biology role model project is Katalin Kariko. Katalin was born in Hungary and grew up on the working class family with no science background. Her father was a butcher and her mother was a bookkeeper. How did Katalin Kariko become involved in science? Katherine's involvement in science began with a profound interest in the natural world during her childhood in rural Hungary. She was also inspired to become a scientist by a high school teacher who always told her that you could be a scientist. And then she went to Joshua Attila University in Jages in Hungary to get the BS in biology and BAd in biochemistry. Catherine's hobby. She liked running and playing. Next, what obstacle did Catherine overcome? Catherine experienced several lack of funding for her research, and in 1995, the University of Pennsylvania demoted her from her faculty position. Admiration. I admire her for perseverance in pursuing research despite losing funding many times. She and I both identify as immigrants to America. Her success in biological research, especially as evidenced by the Nobel Prize in Physiology or Medicine in 2023, show me that opportunity is for everyone, whether you are a citizen or an immigrant. Next, her focus. She focused on molecular biology and biochemistry field, specializing in mRNA, and she spent a lot of time to research stability and medical application of mRNA. She also focused on the question how different RNA types interact with the immune system. This is one of the Catherine recent papers. It's titled as Lyophilization provides long-term stability for a lipid nanoparticle formulated nucleoside-modified mRNA vaccine. It focuses on the lyophilization, a method to research mRNA vaccine for long periods without losing structure. The pictures is one of the figures of the paper. The figure demonstrate the stability and activity of a level apply mRNA vaccine candidate encoding 5-fly luciferase administered either in intramuscular from A to D and intradermally in from E to A in mice. The study compared the performance of the vaccine after various storage conditions, like at the frozen or at the lab light for 0, 4, or 24 weeks. They may track the viable luciferase expression over 9 days, both injection. The main conclusion um, visible in the week 24 panel from the diagram D and H is that larvae mRNA L and B, particularly when stored at 4 degrees Celsius, maintaining expression level comparable to the frozen control, confirming the long-term stability and reserve bioactivity provided by lyophilization. Then, discover and her next step. She discovered a nucleoside-based modification in mRNA, and her key uncovered finding that enabled the development of effective COVID-19 mRNA vaccine like Pfizer, BioNTech, and Moderna. And the mRNA modification is more effective for the therapeutic use. Her next steps are continuing research into mRNA technology and how apply mRNA technology to the other disease like cancer and genetic disorder. In conclusion, Katalin is a symbol of reflex efforts and her research on mRNA has contributed greatly to the creation of the COVID-19 vaccine that have saved millions of lives. And thank you for everyone and watching my video.